Hitting record right now.
All right, hello everyone. We're going to be talking about enable automated testing this week. This is group 8 talking about chapter 10, and we are Jacob, Kristina, and Rafael. The first thing we are going to be talking about is continuously build, test, and integrate our code and environments. So our goal in the end of the day is to always build quality in our products. And by doing something we can do to build that quality is by having developers integrate automated testing into their daily work. This allows us to create faster feedback loops that allow developers to find issues and fix them. An important definition I wanted to point out from this chapter is a deployment pipeline. What that is it ensures that all the code checked into the version control is automatically built and tested in production-like environments. This allows developers to always be testing their code, and this allows them to not have any issues, and the code is always deployable. So another thing about deployment pipelines is the goal of it is to provide everybody in the value stream, specifically developers, the fastest possible feedback of change in that deployable state. The deployment pipeline must also store the history of each code build. This helps us find information on which test it was, what build it was, the builds that have been fully deployed in the environment, and what the test results are for all of those. That just helps us find history of the code and avoid any issues as well. This information also helps us fulfill evidence requirements for audits and compliance purposes, and that evidence is being generated every day. This enables us to create a culture where we don't have to stop the whole production line when our validation tests fail. This obviously saves time and money, so this is why we want to practice it. We also are going to talk about build a fast, reliable, and automated validation and test suite. So imagine you're working on some code and you're working on it, it's fine, you come back the next day and you find that another person has looked at it and it no longer works. What's worse is the problem wasn't a change in the code, it was due to the testing, Q&A working with it, and now 10 other teams are going to be looking at it, and changes are constantly being made in production groups and companies. So in short, slow periodic feedback will be the death of us, especially when you're working with larger development teams. When that automated testing fails, people will wait till the end of the project or wait till another team's done to integrate their part of the work. So when your code's breaking frequently every day when people are looking at it and working on it, it's not going to work. So that's why we want to make sure we have an automated validation to make sure that it's always working no matter who has their hands on it. Ways we could prevent that scenario we were just talking about is we need faster automated tests running in our environment whenever a new change is introduced. This allows us to fix any issues when they occur, and that our product is always in the deployable state we want to be at. Our batch sizes get smaller, our test coverage is always visible, and validation suites don't fail. The next thing we want to talk about is catching errors as early as possible in automated testing. This one is pretty self-explanatory. Find those errors as soon as possible. Because of this, we run faster automated tests, which are called unit tests, before the slower automated tests, which are acceptance and integration tests. And you run both of those tests before you manually go in and perform those tasks. So something we want to do to find errors is use our faster automated tests. That's essential, it's pretty obvious. Errors detected in the slower tests, like integration and acceptance, are very time consuming and hard for developers to work with and reproduce. So when we find those errors in our slower automated services like acceptance and integration, we want to create a faster unit test to find those errors faster, earlier, and cheaper. And this picture right here is just ideal versus a non-ideal, just showed in a pyramid. You can see that in the ideal testing, all the pyramid tiles are automated and you do manual sessions last. In the non-ideal, you're doing your slowest ones first, the manual, and then you're doing the faster ones. So we just try to avoid that.
All right. It's also really important that we ensure that our tests run quickly and in parallel. And we need to run different categories of tests at the same time. That's what that parallel means. Often these tests are going to be running at the same time across many different servers. And we need to make sure that everybody is always using the same build that has passed all the automated tests. And this testing should happen as early in the process as possible. It's very important that we automate as much as we can so that we have fewer manual approvals needed. And we also need to write our tests before we write code. So this is test-driven development. And one of the most effective ways to ensure reliable testing is to write the tests as part of the daily work. We begin every change in the system by first writing an automated test that validates the expected behavior that it fails, And then we write code to make the tests pass. So, and this technique is really important to remember. So it has 3 steps. First, ensure the tests fail. Second, ensure the tests pass. And then third, refactor, fix the code and test again. It's very important to automate manual tests. So it's important to automate as many manual tests as we can. The goal is to find most errors through automated testing to minimize the need for manual testing, but all automated tests aren't a cure-all. They can generate false positives that waste valuable time. And also, we want our testing to be automated, but as they say, quality can't be automated, right? Like, it takes thought processes and that human energy to be able to figure out and solve problems that the machines can't. So we want to automate what the machines can do and preserve our energy so that we can do the things that humans do best, and so that we can focus on that quality. So to prevent this waste of time too, it's better to have like a small number of of automated tests, rather than like a whole bunch of automated tests. And then what we want to do is we want to focus on the tests that are going to validate our business goals to help us achieve what our business goals are. And then over time we can, increase the number of automated tests that we have, but we want to start with just that small number that's super reliable.
All right, the next thing we're going to be talking about is integrate performance testing into our test suites. Performance problems are often difficult to detect, such as when things slow down or things go unnoticed until it's too late. Our goal with that is to write and run automated performance tests that validate our performance across the entire application, code, database, storage, network, etc. So we may build our performance testing environments at the start of any project and ensure that we dedicate whatever resources are already required to build it correctly and early. The next thing we're going to talk about is integrate non-functional requirement testing into those test suites. So test non-functional requirements means that we also validate every other attribute of the system we care about. And we talked about these in earlier chapters, such as availability, scalability, capacity, security, and so forth. Many of these requirements are fulfilled by the correct configurations of our environment. So we must also build automated tests to validate that our environments have been built and configured properly.
And we also need to pull our and-on cord when the deployment pipeline breaks. At any point in time, our automated tests can validate that we have a green build and that we are in a deployable state. But we also need to create an and-on cord so that when someone breaks the deployment pipeline, we can take all the steps necessary to get back into that green build state as soon as possible. And in order to keep us in that state, we will need to create a virtual and-on cord. It's similar to the physical one in the Toyota production system. So whenever someone introduces a change that causes our build or automated test to fail, no new work is allowed to enter the system until the problem is fixed. Why do we need to pull that cord? Not pulling the cord and the and-on cord and immediately fixing any deployment pipeline issues results in the problem becoming ever more difficult to fix, and it makes it so that our applications and environment are really hard to get back into a deployable state. So when we don't pull the and-on cord, our deployments to any environment become as unreliable as when we had no automated tests, or we're using a waterfall method where the majority of our problems are being discovered in production. And in conclusion, in this chapter, we've created a comprehensive set of automated tests to confirm that we have a green build that's in a passable and deployable state. We have organized our test suites and testing activities into a deployment pipeline. And we've also created the cultural norm of doing whatever it takes to get back into a green build state as soon as possible if somebody introduces a change that breaks any of our automated tests. And by doing this, we set the stage for implementing continuous integration, which allows many small teams to independently and safely develop, test, and deploy code into production, delivering value to customers. And that's what it's all about. Thanks for watching.